The universe and distant objects. What do we know about the universe and how do we know it? Astronomy, which is your first code, is the study of the sun, moon, stars, planets, comets, galaxies, gas, dust, and other non-earthly objects and phenomena. What did we know about space back when civilization began? Mayan astronomy was incredibly accurate. They made all of their careful observations of the night sky without telescopes. Observations of the night sky, just like the Mayans made over 4,000 years ago, show you how the Milky Way got its name. What did we know about space before we got space telescopes? We did know a lot. Scaled sizes and distances, however, were wrong, and we knew very little about our galaxy. This is how our Milky Way galaxy looks. It's a spiral galaxy. Galaxy is your second code. Our solar system would be located where the red dot is. Even our radio signals have not left the boundaries of that red dot. One recent finding, there's a supermassive black hole at the center of our Milky Way galaxy. It's called Sagittarius A. Pause the video if you would like to learn in more detail about any of these aspects of our Milky Way galaxy. There are many topics which are sources of active inquiry by astronomers. The universe itself is a source of active inquiry by astronomers today. How did the universe begin? The best supported theory of our universe's origin centers on an event known as the Big Bang. This theory was born of the observation that other galaxies are moving away from our own at a great speed in all directions, as if they had all been propelled by an ancient explosive force. How is it that we study space? Energy emitted in space, including by our sun, is a mix of wavelengths called the electromagnetic spectrum. This radiation allows astronomers to study the universe. Telescopes, including those launched into space, collect and focus electromagnetic radiation so that we can study it. Telescopes above our atmosphere, like the Hubble Space Telescope, can see light energy far more clearly than Earth-based telescopes. What can the Hubble Space Telescope see? Well, since light takes a while to travel great distances, our space telescopes see light that was emitted a long time ago. That allows them to actually see back in time. Hubble is your third code. If you could look at Earth from 65 million light years away, you would see dinosaurs. How do we get our current images of space? Well, once again, it's from telescopes. This image shows how the Hubble telescope lens size compares with the next generation. We're bound to learn even more as the new space telescopes send information back to us here on Earth. Here are pictures of nearby galaxies taken by the Hubble Space Telescope. Notice how small the Earth is when compared to our galaxy and superclusters of galaxies, and ultimately the observable universe. Astronomy is unlike other sciences. Except for the Moon and Mars, there are no experiments we can perform, nor expeditions we can mount to manipulate the actual objects of our study. These are the only places that humans or robots have been so far. This infographic shows the distances we have traveled in space, on Mars and the Moon exclusively. This dotted line represents the distance of a typical marathon race. Our eyes can see visible light. That only gives a small part of the full story, though. Imagine a song played by a symphony with only one instrument played and the rest silent. Because the light takes so long to get to us, we are always seeing the past. Here's an example from the Mars rover. Communications from the lander took 20 minutes. So vital information for the rover not to drive off a cliff arrived too late. Light takes 400 years to arrive to us from the red supergiant star in the constellation Orion named Betelgeuse. That star could have already exploded. It could have become a black hole. We only know what it was like 400 years ago. In Orion, nebulas exist in the constellation Scabbard, the sword holder. Nebulas are where new stars and solar systems are being formed. It takes 1,344 years for light to reach us from the Orion Nebula. These nebulas are other examples, and all of the pictures were taken by Hubble. In the Hubble telescope views, the darkest regions showed star density. The most dense parts are where new stars are forming. The object to the right shows a solar system forming around one star, which is about the same size as our star's solar system. How does our sun compare to other stars? Our sun is actually a medium-sized star. How does our sun compare in age? Our sun is actually a middle-aged star. In about 5.5 billion years, our sun's hydrogen will run out, stopping the fusion reaction which turns hydrogen into helium and gives off energy. Pause the video if you would like to learn in more detail about any of these aspects of the birth and death of stars. A star like our sun, burning itself out and then exploding, will look like this one. It will become a red giant star. Red is hydrogen and green is oxygen. A star like Betelgeuse, a red supergiant, burning itself out and then exploding, will look like this one. It will then collapse under the pressure and become a very dense black hole. Different elements burn in different colors. This particular explosion eventually will form a new solar system. There are 100 billion solar systems in our galaxy. 10,000 galaxies are shown in this one image. They are all moving away from each other. This shows clusters of galaxies. You can see the blue shifting light. This is evidence of the universe expanding, justifying the Big Bang theory. Light shifts to blue when objects are moving away from you. This periodic table shows which astronomy-related events brought about each of our elements. Here's our first notable scientist in astronomy, Isaac Newton. He was able to describe gravity. And the universal law of gravitation, understanding gravity is complex. It results from the unequal distribution of mass and energy in the curvature of space-time. Imagine a trampoline with a large person in the middle. Smaller people will fall towards the larger. The pull of gravity is proportional to the masses of the objects and inversely proportional to the distance between them. Our second notable scientist in astronomy is Albert Einstein. He was able to describe the general theory of relativity. Gravity, especially when it is strong, slows time and bends space. The amount of that slowing and bending depends on how much matter and energy are present. The relativity part is because everything in the universe is moving. Nothing is in fixed position, so our place is always located relative to other objects. Our third notable scientist in astronomy is Vera Rubin. Dark matter is dark because it does not emit light. Vera Rubin provided the first direct evidence of it. Dark energy is the mystery. We know how it acts, but we don't know what it is made of or how to show evidence for it. Einstein united the concepts of space and time with the concepts of energy and mass, but his theories are incomplete and don't fully explain the actions of fundamental particles. Dark energy explains those actions, and dark energy is your fourth code. Our fourth notable scientist in astronomy is Dr. Neil deGrasse Tyson. He began the discussion which led to Pluto becoming a dwarf planet. It was large enough to become spherical, but not large enough to clear its own orbit. We still continue to test ideas, look for measurable, observable evidence to give us answers about the universe and distant objects.